students, today we are going to see some more interesting and important questions from MS Chouhan sir's organic chemistry and level 1 question from 111 to 120. Come on, let us discuss the first question. Pure S2 or butanol has a specific rotation of 13 plus 13.52 degree. A sample of 2 butanol prepared in the lab and purified by distillation has calculated specific rotation of plus 6.76 degree. What can you conclude about the composition? They have given that composition, that is RS configuration, 50 percentage of S and 50 percentage of impurity, 50 percentage of S and 50 percentage of R, and 50 percentage of S and 50 percentage of racemic and the other mixture. Now come on, let us discuss this question clearly. So here 2-butanol they mentioned very clearly. So 2-butanol, how do we write it? 2-butanol. So 2-butanol, 4 carbons will be there. In that second carbon, OH will be available. So here actually RS rotation. So in this, here pure, this is actually pure minus 2 butanol, right? Butanol. That is what it has mentioned. So here we are going to see that data, how much what it is here, plus 13.52 degree, and the mixture they have given as sample. Sample means mixture, so it will be plus and minus, both will be there. So a sample of 2-butanol prepared in the laboratory and purified by distillation has calculated specific rotation. So in that sample here, how much it has mentioned, so that means sample, instead of that we can write it mixture. So mixture, how much it is? We got it, that is plus 6.76 degree. Now, I would like to mention to find this answer in one small formula. So what is the formula? Optical purity. Optical purity. So optical purity is equal to mixture divided by what it is? Pure compound. That this is pure compound. No, this is pure, right? Pure 2-butanol. Pure compound into 100. This is only the formula, right? So optical purity we have to calculate it, so that we can identify what is the percentage of RS or S only or R only, like that we can identify. So here S butanol they have given, S butanol. So how much it is there for each? Let us identify with this small formula. So here what it is, mixture, how much they have given? Here mixture it is 6.76 degree divided by, and pure compound how much they have given? 13.52, sorry, 13.52, right? 52 degree into 100. So when you calculate this value, you will get 50 percentage. So that means here optical purity, what it is? 50 percentage. So 50 percentage related to what it is? S compound. This is S butanol, right? So this is related to that S compound only. So that means 50 percentage, 50 percentage will be yes butanol, then other 50 percentage, so only 50 percentage we got it. So that means other 50 percentage, where it will be, it might be racemic mixture. So here actually impurity is racemic mixture, it is impurities only. So in that racemic mixture it will be 50 percentage, right? So that means this is 20% 25 percentage, and here 25 percentage. So 25 percentage 25 percentage means here might be R and yes. Okay, so here 50 percentage yes and 25 percentage yes. So altogether yes will be 75 percentage, right? And what it is, R will be 25 percentage. So 50 percentage pure it will be yes, and other it will be impurities will be available. So that is what racemic mixture it is, R and S, very clearly it has mentioned. Now which is the correct option what they have given here in this point? Here 50 percentage of yes and 50 percentage of impurity, 50 percentage of yes and 50 percentage of R. This will not be applicable. Why? Because here 50 percentage in the 25 only RS it has got. So that means this will not be applicable. And the same way 50 percentage yes and 50 percentage racemic mixture, yes, of course. And here some other mixture, so this will not be applicable. In that 50 percentage yes and 50 percentage racemic mixture, it will not be 50 percentage racemic mixture. So here 50 percentage, but here RS 25 and 75. So here what it is, you see here only 50, here it has got yes, actually it has got 75. So naturally what is the correct option? We can bring it over here, means option A only we can bring. Why? You know, because 50 percentage yes and 50% impurity. So option A only we can bring for this question. Come on, let us go to the next question. I hope you got the clarity. Come on, let's go to the next question. Actually, determine the absolute configuration of the chiral centers of the following compound. Absolute configuration we have to identify. They have mentioned here A and here B. So as we go for this compound, here they mentioned CH3 on the dash position, and Br it has mentioned in wedge position, and this is CHO, right? CH3 and C double bond O in that H will be available. Okay, now let us find the complete absolute configuration according to CIP rule. So CIP rule, you know very well. Fourth priority is there on dash. Clockwise is or anti-clockwise is yes. If at all you change into dash and bring it according to that clockwise or anti-clockwise, yes. In that first A point, it has mentioned here CH3, it is there, but here it is actually dash position. You have to convert it into wedge position, right? So that is what I just mentioned here. Wedge and dash, here actually interchanges taking place. So interchanges taking place means here the point will be going out, here 1 and here 2, and then this is 3 and this is 4. So you will get that anti-clockwise. So anti-clockwise means according to that fourth priority is there on dash, anti-clockwise means yes. So A point it is yes, right? Now we are going to see the B point. Now in that B point, higher priority goes to bromine, right? Now here bromine, so this is 1, and of course C double bond O, this will be 2, and this is 3, and the hydrogen here, there is one hydrogen I just mentioned here, so this will be 4. Now I just mentioned here only for you to get that identification. So this is 1 and this is 2 and this is 3 and this is 4, right? Now what is that according to that yes and R? So here the fourth priority is there on dash, hydrogen is there in the dash position only. So how will you bring it here? Anti-clockwise only. So here also yes. So option A, that means point A also you are getting yes, point B also you are getting yes. So both yes, yes configuration only. So which is the correct option according to that? Here A, R and B, yes, this will not be the correct option. A, R and B, R, this also will not be the correct option. A, yes and B, yes, yes, C is the correct option, and D, yes and R, no. So which is the correct option? Option A, yes, and B, yes, both or yes, yes configuration. Hope you got the clear idea of according to that CIP rule. CIP rule, actually they have given that VIP to identify RS configuration. Come on, let us go to the next question. Number of stereoisomers possible for following compounds. So how many stereoisomers are possible in this compound? First and foremost, we have to check whether it is symmetrical or unsymmetrical. 100% it is unsymmetrical only. You see here, as we observe here, it is completely different. Okay, so this is unsymmetrical. So then how many chiral center it is available? This is one chiral center and this is one chiral center, and of course it is GI, it is available here, and here GI it's available, and added to that here ring structure also it is available. So chiral center it is 2, and ring, how many ring it is available? It is 1. Okay, now first and foremost, this is unsymmetrical. Unsymmetrical means what is the formula for to identify the number of stereoisomers? Unsymmetrical, symmetrical. So unsymmetrical means total number of stereoisomers, total number of stereoisomers. So what is the formula here? 2 to the power of n. N equal to what it is? N equal to n equal to 3. How do you get the 3? Chiral center 2 and added to that 1. So this is altogether 3. So 2 to the power of 3. So you will get 2 into 2 into 2. So you will get 8. So which is the correct option? Option A. 8 isomers are possible in this compound. Hope you got the clarity about this question. Come on, let's go to the next question. Which is the correct structure of D-glyceraldehyde? As they have mentioned glyceraldehyde, which is the correct option? That is, we have to identify. This is very easy to identify. When that OH group is there on the right hand side, OH group is there on the left hand side, easily we can identify. So capital D, capital L. So that is capital D and capital L. So here OH group on the right hand side. So right hand side means this is D, and the same way OH group on the left hand side, that is L, capital L. Okay, now as we observe here, one more point I wanted to mention. Higher priority always goes to aldehyde. Wherever aldehyde is there only we have to start. Whether it is top or bottom, that we will consider the same OH group which is there on the right and left. Okay, now I'll mention here. So here always starts from here 1 and 2, 3. So in the 3 carbons, here OH group is there on the right hand side. So that means this is a D-glyceraldehyde. And the same way here CHO is there on the vertical side. Now we have to interchange. So interchange means this CHO will go on top and the hydrogen will come, and the same way here also it will convert, because one interchange, another 2 interchanges. So 2 interconversion. So automatically how much you what is the confirmation you will get? CHO, and here OH, and here H, CH2 OH. Now OH is there on the right hand side. So OH is there on the right hand side means what it is? D-glyceraldehyde. This is also D-glyceraldehyde. And the same way, now another one more point. Now top it is there, easily we can identify. Deglyceraldehyde means right hand side OH, it has to be present. That is only we can say deglyceraldehyde. Suppose CHO is there on the bottom. Now here we have to start wherever there is a higher priority, that only we have to give that number 1, right? So 1, 2, 3. So in that bottom to top, that means from where there is 1, from there we have to count bottom to top at a CHO, and then OH is there on the left hand side. So that means this point we can mention it as a deglyceraldehyde. Okay, let me give you that idea for you. So this is also deglyceraldehyde. Right, now I would like to mention very clearly how do we identify. So top to bottom. So top to bottom, OH group is there on the right hand side. So this is a deglyceraldehyde. And the same way, bottom to top, I just mentioned bot. Okay, bottom to top. So here OH is group is there in the left hand side. Left hand side, this is a deglyceraldehyde. Got it? Okay, so now here come to this point. So top to bottom. So here top to bottom, OH group is there on the right hand side. This is deglyceraldehyde. Generally, OH group is the first priority. According to that, you will go. So top to bottom, OH group is there on the right hand side. That is deglyceraldehyde. Suppose if it is bottom CHO, higher priority, wherever it is there, we have to start. Otherwise, we have to convert this one. That will be more. It will take time. So from here, 1, 2, 3. So now bottom to top, OH is there on the left hand side. Now this is the left hand side. No, that is also glyceraldehyde. Now, how do we identify L-glyceraldehyde? Suppose if it is L, the same way, top to bottom. All right, right. OH group, right? OH group is there on the left hand side. Left hand side, that is L. Right. Now, the same way, bottom to top. Bottom to top, OH group is there on the right hand side. That is also L. I hope you got a very clear idea. How do we identify that D and L configuration? Suppose if they are giving like this. Okay, now in that, which is the correct option? This is deglyceraldehyde. This is also deglyceraldehyde after interchanging, because CHO should go there on the top according to that. And then from bottom to top, as I mentioned here, bottom to top, OH group is there on the left hand side. Deglyceraldehyde. Yes, you got it. So which is the correct option? All these molecules are belongs to deglyceraldehyde. Yes, come on, let's go to the next question. I hope you got the very clear idea about D and L configuration. To see, that is CH2OH, CH2CHO. In that, which conformer of above compound is most stable? Consider conformer across C2 and C3. Now, you just observe here C2 and C3. So that is what I just mentioned, CH2OH, CH2CHO. So this is front carbon, CHO, it's a front carbon. Front carbon and back carbon. Back carbon, it is a round circle. Front carbon, it is a line. So this is a front carbon and back carbon. So in that, staggered, gauge, fully eclipsed, partially eclipsed. Of course, 100% they are asking about most stable means these two will not be applicable. Why? Fully eclipsed and partially eclipsed will not be applicable for this statement. Right. Now, staggered and gauge. In that, I just to bring it to your notice. So here, actually, completely, this is gauge. This is what it is, gauge method, and this is anti. Right. Now, in this point, here, CH2OH here, CH2OH. So CH2, first center carbon it is there, CH2, CHO, this is front carbon. And the same way here, back carbon CH2OH. And the same way here also, of course. Right. Now, in that, what do you observe? Here, gauge conformation. Here, oxygen is available. Here, hydrogen is available. Both are having an intermediate connect. What it is called? Intramolecular hydrogen bonding. Intramolecular hydrogen bonding. You know what is that intramolecular hydrogen bonding? It will be more stronger, like a brother and sister relationship, like that within the molecule, the bonding it is taking place, and it is more stronger than any other bond. So that bond it is available here. So this will be more stable than anti. So what it is here in this point, CHO and OH, just to that it is actually less repulsion because it is far away. So it is less repulsion. So, which is the correct option? I wanted to bring it here. Option B, gauge conformation. It's more stronger. Why? Because intramolecular hydrogen bonding you can identify over here in this molecule. Hope you got the clarity. How do we get that idea about this answer from this question? Come on, let's go to the next question. Next question, it's very simple. Let us go and identify that D and L configuration, how we have identified RS configuration according to that CIP rule. Here, we are going to identify D and L configuration according to IUPAC system. Here, higher priority goes to CHO. And the previous question, previous question, we have gone through deglyceraldehyde. How do we identify D and L configuration? I have given the tricks for you, the same idea. I just bring it to you here. So, in the top to bottom OH group on the right hand side, D. And the same way, bottom to top OH group on the left hand side, D. Top to bottom OH group on the left hand side, L. And bottom to top OH group on the right hand side. Yeah, right. Come on, let us identify. And here, two chiral center it is there. Only one chiral center D and L, very easily we can identify. Whereas 2 chiral center, the last chiral center, OH group, where it is located, right or left, according to that, we have to give the D and L configuration. Now here CHO higher priority according to UPAC system. Right now, come on, let us go and identify here 1. CHO1, here 2, and this is 3, and this is 4. So in that OH group, which is located on the right hand side, that means bottom to top OH group on the right hand side. Bottom to top OH group on the right hand side, L configuration. Yes, this is L configuration. And the same way, next, this is OH group. Let us check it where it is. 1, and this is 2, and this is 3, and this is 4. OH group, last chiral center, where it is located, OH group. So that means here OH group is there on the left hand side. So bottom to top, OH group on the left hand side. So this is D, right? And the next one, CHO, higher priority 1, and this is 2, and this is 3, right? 4. So 4, it has to turn. So that means here, how can you change it here? The same way, here CHO, and then here what it is? HOH. So here only we are changing, right? So that means here changes, here also it will be changing. So here OH will come, and then that OH will go here, and H will come here. So here CH2OH, and then this H. Yeah, I'll change the color so that, so here H, here OH. So that means here priority comes in that top to bottom. So that means here 1, here 2, here 3, and this is 4. Last priority, that means last chiral carbon, where there is left hand side OH, it is coming. So top to bottom OH is there on the right hand side D, bottom to top. Now top to bottom OH is there in the left hand side. So this is L. See, now 1, 2, 3, last chiral carbon, where there is OH is located, that is only we have to identify. So due to that interconversion, here L. So that means this part which is called L configuration. Now, which is the correct option? LDL. So where LDL configuration? Yeah, LDL. Here it is B option. It's a correct option. I hope you got the clarity. How do we identify? It's very simple. I hope this tricks will help you to identify the correct way. How many isomers have the name bromomethyl cyclopentane, ignoring chirality? So here bromomethyl cyclopentane, how many isomers are possible? So chirality we could not identify, so that we cannot go for the symmetrical or unsymmetrical according to that. So in that way, this is bromomethyl cyclopentane. This is 1 bromo 2 methyl cyclopentane. This is 1 bromo 3 methyl cyclopentane, and this is 1 bromo 1 methyl cyclopentane. In that 4 isomers are I have drawn, and another 2 more it is possible. You know what are those 2? Here in this point, here wedge will be available. So in that wedge, and it is a dash, that means it is a cis and trans. It is possible the same way cis and the same way trans. This also here wedge and here dash I just mentioned. That means this also it is possible cis and trans. So altogether, how many isomers are possible? Means here already 4 plus 2. So cis and trans, it is 2 in this 2 compounds. So that altogether it is 4. 2 plus 4. So altogether 6 isomers are possible. Now, which is the correct option? C. 6 is the correct option. I hope you got the clarity about this point. Come on, let's go to the next question. The next question we are going to see, that is, which of the following compounds can show geometrical isomers? It's very simple. Geometrical isomerism, how do we identify? Carbon, that is C double bond C, here group A, and this is group B. Right, and the same way this side also group A, and this is group B. So that means different groups or atoms which is attached to that chiral carbon. So this is chiral carbon, this is geometrical isomers. So this can show geometrical isomers. I hope you got the clarity. How do we identify geometrical isomers? So both should be different groups or atom which is attached to the chiral carbon, that is called geometrical isomers, like cis and trans, right? So A, it is cis, B, suppose AB, it is trans in that way. Come on, let us check here in this point. Option A, here both are chlorine, both the side chlorine, whereas here bromine, iodine. Yes, fine, that is, but here both are same. So this cannot show geometrical isomers. Whereas here this is CH3, and here also CH3, this carbon which is attached with double bond and cyclo compound. This also cannot show geometrical isomerism. Whereas here C double bond C, here fluorine and chlorine fine, but here ethyl, both the side ethyl it is there. So this also cannot show geometrical isomerism. So it has to be a different, like this it has to be there. Right, now the last one here, CH, the cyclo compound which is connected with the C, CH3, but whereas this side CH3. I will explain you very clearly how do we identify. Now in this point here, cyclo compound which is connected with double bond C, here CH3, and then this side CH3, whereas here both the side wedge, right? So wedge, it is CH3 and here CH3, right? And the same way the next point here, cyclo compound, here double bond C, here CH3 and here CH3, and then this side it is wedge and this side it is dash. here. So that means this is cis and this is trans. In that way, this can show geometrical isomers, whereas other than these three, it cannot show geometrical isomers. But in this point here, wedge and a dash can show geometrical isomers. So geometrical isomers, very important point to be noted down. It can show cis and trans geometrical isomers. So that is what. So option D is the correct for geometrical isomers. That means option D can show geometrical isomers. So which is the correct option? Option D. I hope you got the clarity. Come on, let's go to the next question. Structure represents meso compound. See, meso compound means what are the main points to be noted down, So here meso means minimum 2 chiral center. It has to be there and identical. And next one, what it is? A chiral, and it is superimposable mirror images. This is actually superimposable mirror images. So these are all the points are applicable for meso. Come on, let us check whether these points are applicable here or not. So as we are checking here, methyl group and here also methyl group, and this side it is dash and hydrogen side it is wedge. Whereas here methyl group, yes, dash is there, but wedge another methyl. So that means these both are not identical. See, this is wedge and dash. This is dash and hydrogen side wedge has gone. So that means this is not identical. So this cannot show meso compound. And the second, B compound. So as we are looking at the dash side hydrogen is there, here also dash side hydrogen is there, whereas here bromine wedge side it is there. So that means this is similar to chiral carbon, it is there, identical, and it is achiral. Yes, this is having what it is, meso. This is meso compound. Okay, so this can show, that is mirror images. This is superimposable mirror images, right? And it cannot show optical activity. Now next one, hydrogen. So this is B point, it can show meso compound. Then this one, this is hydrogen which is attached with the dash, and this side hydrogen is attached with wedge. Now you see here only wedge and dash, it has changed. So that means this is chiral compound. So both are in a different. So this cannot show meso compound, right? And the next one, and here actually there is no chiral carbon only here. See, in this point you cannot identify any chiral. See, is there anything same? No, the side you cannot find the same over here, right? So that means this cannot show meso compound. Now, which is the correct option? Option B. So please note down while checking with that meso compound. These are all the points meso compound, right? Come on, let's go to the last question. The next question. CH3, CHOH, COOH. How many representation of lactic acid are possible in Fischer projection D and L? Okay, now we are talking about D and L. RS configuration also, we can bring it over here. RS absolute configuration, so that it will be easy for us to remember. Yes, R or yes, anything, right? Now come on, this is COOH and OH, CH3 and H. Higher priority goes to where? Here, that higher priority OH, it is first one, and this is second one, and this is third one, and this is fourth one. So fourth priority is there on the vertical. So here what it is, anti-clockwise. So anti-clockwise means what it is, here anti-clockwise means R, right? Now the same way we can draw for that S also. Now how do we draw that S? Let me draw for you. So this is here in this OH, I can bring it here, OH, yeah, here OH, and here COOH, and then here CH3, and then here H. Now, how do we bring it here in this point? 1, priority 1, and this is 2, and this is 3, and this is 4. So that means this is 1, 2, 3, 4. This is clockwise. So clockwise means what it is. Fourth priority is there on vertical. Clockwise means it is what it is. Yes, right. So this is R and this is yes. We got it. Okay, now in this point, first and foremost, this is completely non-superimposable mirror image, right? So this is completely what it is, non-superimposable mirror image. Just I'll draw this non-superimposable mirror image. Both the thing, it is non-superimposable mirror. So non-superimposable mirror image, RS configuration means this is first and foremost enantiomers. Enantiomers, right? Enantiomers means here actually a non-superimposable mirror image, right? Now in that point I wanted to mention D and L configuration. Here 12, here 12, you will get it. How do we identify this 12 plus 12? Here you will get what it is, 24 isomers are possible. Now how do we identify in a practical way? That means 4 factorial. So how do we go for 4 factorial? So how do we go for? So that is 4 into 3 into 2 into 1. Why do we go for in that way? Chiral carbon that is connected with 4 different groups, that is hydroxyl group, methyl group, CO, that is a carboxylic group, and hydrogen. So there's 4 different groups attached. So that means here what it is, 4 into 3 into 2 into 1 according to the priority order, 1, 2, 3, 4, right? So in that way what it is, 3 4s are 12 plus, now what it is, 2, 24 into 1, 24 only, right? So 24 isomers are possible. So which is the correct option in that? option C as the correct option. I hope you got the clarity. Option C as the correct option. Come on, let us go to the next question in our next video and